Yeah, we gotta visit the DFS. DFS basically is the technique is like this, right? So here, whatever any, so DFS from top nodes. This is top nodes. You go down here, go down here. Is once you don't have children nodes, and you're coming back, and you do something, and you're coming back, and here you finally have children nodes. Go here, and then coming back, then come back, finish the DFS. Basically like this. So DFS code is always test. There are two parts, right? The two part. First part is will be here. Yeah, this is DFS, right? This is DFS because we store the data. We store the data use adjacent set. So what we have here is the when we store here. So in here, this is 1, 2, 3, 4 here, right? So one will have two. Definitely have two. What about two? Two, for easy way, we will store 1, 3, 4. So basically two will have one here. So for standard code, we always checking if, so when you, for the DFS code, you always have children and parents like this. So this is children, this is parents. You will tell the pair, like this pair coming here, then you do the process, right? And here you have your own children, like Chitozi. But you know which one is your parents. Basically, you know this. Basically, you're passing these two and do the DFS, right? So in the here, you're always checking if, because this one theoretically also in nodes children. From picture not, but from the array list, this is one. So here you will see, so this standard code for each one the children here, if it's not equal to parents, then do something, right? So this is a standard, this is standard code. So yeah, and the DFS. For the DFS, what do we gotta do? We gotta remember, first of all, we know, we can know the length, right? We can have the like bunch of array to help you to do that. So basically, this is sometimes you have the deep length, right? Deep, or maybe distance, and also visit, and other thing you create to help these things. The DFS is very useful. This is standard one, and let's look at that question. Let's look at this question. It's called phenomenal review here, right? So yeah, let's look at this sample here. This sample here, he told you there's a attraction, and there's a 5, you must go. 5 you must go, right? So 5 you must go is 06437. 06437. This must go, and here give you the map, and you're linking together, and it asks you to find a minimum max, right? So minimum here is 6. So you start from, he told you start from 6 is maybe the best. Start 6, and go 1, 1. This is go 1, 2, 3, 4, and 5, 6, 7. Go to the end with that, right? So this is kind of like the question. So usually this graphic one, CDC like to test you to DFS. DFS, okay? So first, what happened here? First, we got to analyze the question, say here, to solve this one, we got to know, basically for the tree, the distance, final distance of what, right? So if bunch of like, if you like, let's say you start from the middle, you go here, go here, go here, it's not that good. So this very obviously, if you start any end, if you start from the edge, if you start from the edge, not edge, if you start a no leaf one here, always the best, right? It's always the best. So let's see, start from here. How can we quickly calculation these things here, right? Yeah, so this is the skill here, right? Basically, every time, basically, let's assume you take this one, you took this one, right? You took one way to go somewhere, right? But anytime you go outside, could be here, you go outside, right? Anytime you go outside, let's say this is the main road. Anytime you go outside, you always need to come back, right? Doesn't matter here have how many nodes here, right? So let's say go here, even like this. For example, let's say this is main. We assume this is main row, and we go outside here. And every time we go outside, you gotta go back to the main row, right? Always go to back. So this nodes always need to double. Like see here, right? We go here 1 and 2. This one always count to 2. And they go here 1 and 2. It's always count to 2, right? And this one 1 and come back here. So always count to 2. So this one go back here, count to 2, count to 2. So this 1, 2, 3, 4, 5. So for this row, it's always count to 2. Should be like 5 times 2, right? So should always, if we think this is a main row, right? What a main row help us, right? The main row help us is don't need to go back, right? Main row you don't need to go back. So what do we save? We save the go back time, right? We save the go back time. So therefore, from here, we just calculating all the nodes here. All the nodes were times 2 is times 2. And the minus, what do we save? What do we save? We save the longer distance. We gotta know what is the longer distance, right? Longest distance from one node to the other one, right? What is the longest? So DFS really help you to do that, right? So for that question, in the beginning, what do we do? In the beginning, what do? We're trimming this one, right? Let's say here, nodes here, right? Yeah, let's say for example, this is a restaurant we want to go. Okay, so when we do DFS, go here, go here. If this one, you don't want to go, so we just don't do anything. Come back here, right? If this is we want to go, then we tell the parents also we want to go because we gotta go through the parents go this one. So if this one we want to go, we mark this one we want to go, and we mark this one also we want to go, and we go here. This one we don't want to go. Come back here. Don't want to go. So we go first round. The first round DFS. What do we gotta do? We get rid of all the one don't want to go. The first round DFS. So it's very clean. We have the nodes. Have all the age we want to go, right? So this one no more. It's kind of a trimming. No such things, right? So it's one way. Okay, so this code is here, so DFS here, so basically this is called DFS 1. So here for all the children, if it's not the parents, then we continue to. If no children here, go in. Right? So you always return, with no children, if hit the end, you return the, if the end, what do you go? If hit the end, you return the status. Is that what we want to go? Oh, no, don't want to go, right? Here, but, right? So there's a one tricky here. We got a calculation how many total phenomenon restaurant we have. So we gotta be -1. That one's like we're cleaning, right? After trimming, we got recalculation how many restaurant we revisit, right? And here's the code. If it's true, what happened, right? If it's true, we tell parent. If it's true, it's parent. If my children is true, we tell parents also true because we go through the parents. We go through the parent. If I'm true, then parents also true. After this one done, we have all the true here, right? So we have a bunch of picture like this. So everywhere is true, right? Anyway, let's see. Everywhere true, right? So here all true. Now what do? Now we gotta go back find the longest distance. How to find the longest distance? We do 2 DFS, right? We do 2 DFS. We do. We first start anywhere. we start anywhere, so anywhere. So we go here, we go anywhere. Then we find the longest distance. The longest distance is must be like far edge, right? Gotta be, must be. So like this is one way, right? So we go first DFS here. We go first DFS. In the first DFS we're using this one, yeah. So DFS is very simple. So this is the same thing, right? So you can do any code, you write your own code, it doesn't matter. So basically with first DS we keep going, anytime we go deep and we plus the distance is 1, go back, this distance is 2, and then come back, right? So like this. So in this part we will find out who has the longest one, right? Anyway, the longest one. If the same, doesn't matter, right? Longest. The second DFS, now we know which one longest, we use this one. Let's say this is the far one, using this one. Then you do another DFS. First DFS we random pick. We find one, and second one we find this one. We go here and find the longest one. Maybe here, right? Maybe longest one here. Then we find this one. Now this time we can use the formula. The formula is because this one is all what we gotta do, right? So here's the formula. Formula is this one, right? So this n minus 1 and do that one. So this is very important. DFS is very, very important for the CCC. So we got very familiar with this one.